Today we're going to begin to learn about Earth's seasons, why we have seasons, how they're different from each other, and how the Earth's tilt creates those different seasons that we observe. So what we're going to do first is read through the front page, and yes, I am going to read it to you because otherwise you won't read it. The Earth's seasons are not caused by the differences in the distance from the sun throughout the year. These differences are extremely small. The seasons are the result of the tilt of the Earth's axis. The Earth's axis is tilted from perpendicular to the plane of the ecliptic by 23.45 degrees. It's tilted off of perpendicular by that much. This tilting is what gives us the 4 seasons of the year: spring, summer, autumn, and winter. Since the axis is tilted, different parts of the globe are oriented towards the sun at different times of the year. Summer is warmer than winter in each hemisphere because the sun's rays hit the earth at a more direct angle during the summer than during winter, and also because the days are much longer than the nights during the summer. During the winter, the sun's rays hit the earth at an extreme angle and the days are very short. These effects are due to the tilt of the Earth's axis. Big idea from this paragraph. The seasons are due to the tilt, not how far away we are from the sun. Solstices. The solstices are days when the sun reaches its farthest northern and southern declinations. When we learn about the sun rising and setting, we're always taught that the sun rises in the east and sets in the west. And it actually varies off of directly east and directly west by just a little bit, and that's called its declination. So how far it varies from directly east and directly west, that's its declination. And on the farthest declinations, we have our solstices. The winter solstice occurs on December 21st or 22nd and marks the beginning of winter. This is the shortest day of the year. The summer solstice occurs on June 21st and marks the beginning of summer. This is the longest day of the year. We also have days that are called equinoxes. Equinoxes are days in which day and night are of equal length. The 2 yearly equinoxes occur when the sun crosses the celestial equator. So our equinoxes mean that we have equal length day and night. The vernal equinox occurs in late March. This is the beginning of spring in the northern hemisphere and the beginning of fall in the southern hemisphere. The autumnal equinox occurs in late September. This is the beginning of fall in the northern hemisphere and the beginning of spring in the southern hemisphere. Let's see if we can answer these questions now based on what we have read. Are the Earth's seasons caused by the difference in the distance from the sun throughout the year or the tilt of the Earth's axis? Hopefully you picked up that the differences are caused by the tilt of the axis. What is the tilt of the Earth's axis in degrees? The reading on the front told us it was 23.45 degrees. Your book, I believe, just gives you 23.5 degrees. During which season do the sun's rays hit the Earth at the most direct angle? That would be the warmest season, which is summer. During which season are the days the shortest? That would be our coldest season, which is winter. Remember that it's a combination between the length of the days and the angle of the sun that gives us summer and winter. What is the name of the shortest day of the year and the beginning of winter? That is called the winter solstice. What is the name of the longest day of the year and the beginning of summer? That is called the summer solstice. Pause here if you need to write this down. I will be erasing to move to the bottom of the page. Number 7, what is the name of a day in which the day and night are of equal length? That would be called an equinox. When days are equal, we have an equinox. Day and night are equal. How many times each year do we have days where the day and night are of equal length? That would be 2. What are the names of these days specifically? the vernal equinox and the autumnal equinox. Autumnal is pretty easy to remember that that's the fall equinox, but how do you remember that vernal is the spring equinox? I think about a connection to Spanish. What's the word for green in Spanish? And if you're in Spanish, hopefully you know that the word for green is verde. That means green. Those two words have the same root in Latin, so the vernal equinox has to do with the root word for green. That's in the springtime when everything turns green. So hopefully that will help you remember that. If the northern hemisphere is having spring, what season is it in the southern hemisphere? And the southern hemisphere is opposite of us, so that would be autumn or fall. Pause here if you need to write this down. I will be erasing to go to the next page. What we'll do next is a comparison between direct and indirect rays. We've already talked about this once this semester with the flashlight lab back towards the beginning of the year. We're going to look at it again with this diagram of the Earth and the sun's rays in 3 different positions. Half of the Earth is constantly in sunlight. All sunlight has the same amount of energy. Each ray can provide the same amount of heat, but all places on Earth do not receive equal concentrations of sunlight. We have 3 different sun rays here, and even though it looks like the Earth is straight up and down in this picture, that is just for the purposes of the diagram. The Earth is supposed to be tilted and it's the sun that's straight up and down, but for the purposes of the diagram or of the picture, the Earth is straight up and down and it appears as though the sun is tilted, even though we know that that's not actually the case. So there's a different amount of Earth's surface that's covered for each of the different rays. You can see that here. We also have a scale at the bottom that tells us for the approximate length of each of these, how far is that in miles. So each of the sun's rays is a 1/2 inch wide when it starts, and then we can see how that spreads out over the Earth's surface when it hits Earth. Okay, let's go down to the questions. Look at the sun's rays A, B, and C. Measure the amount of Earth's surface that each sun ray covers and use the scale below to determine how many miles this is on the Earth's surface. You can take a plain piece of paper and copy the scale onto the paper and use that, or if you have a ruler, you can use a ruler. We're just going to be measuring approximate distances here. I know the surface in the picture is curved and your ruler or your note card is straight. We're just doing approximations. Pause here to measure and record the length of the Earth's surface that's covered by each of those rays. Okay, now that you've done your measuring, you should have found that ray A covers somewhere between 1 and 1 1/4 inches. That would translate to approximately 1,100 miles, give or take a little bit. Again, we're measuring a curved surface with a straight ruler. Ray B covers approximately a 1/2 inch, which would be approximately 500 miles. And ray C covers approximately a 1/2 to maybe 3/4 of an inch. And so we could estimate that at about 550 miles. Number 2, which ray, A, B, or C, spreads out over the greatest distance on the Earth's surface? That would be A. Number 3, which ray, A, B, or C, spreads out over the least distance on Earth's surface? That is B. Number 4, if the same amount of heat covers a smaller area, will it be warmer or colder than a larger area? And it will be warmer because there's more heat per square. Per square, more heat. And I'm referencing back to your flashlight lab with this one. When we had a more concentrated beam on the flashlight, we counted the squares. There were less squares covered. That means each square gets more heat. So more heat for a smaller area. Number 5, why is it warmer at the equator than at the poles? And that is because the sun has a direct angle. Or again, remember from the flashlight lab, this was a high angle all the time. And you can see that in your picture. Ray B is supposed to represent the one that's at the equator. Pause here if you need to write this down. I will be erasing to move to the next page. Last page. Why are there seasons? Here is a model showing different phases of Earth as it revolves around the sun. It takes Earth approximately 365 days or 1 year to complete one revolution around the sun. As it revolves, Earth is also rotating or spinning on its axis. The axis is an imaginary line drawn through the planet from the North Pole to the South Pole. Earth's axis is tilted about 23 degrees relative to the sun. Looking at this first diagram, use the model above and explain why the Earth has seasons. The tilt is what causes the seasons. So if you look at June over here, it's pretty obvious that during June, the northern hemisphere is tilted towards the sun. And that's, of course, when we have summer, so we get the most direct rays. If you look over here at December, again, it's somewhat obvious that the northern hemisphere is tilted away from the sun. So that would be when we get the most indirect rays, and that would be the coldest. It also has to do with the length of the days during those seasons. During the summer, we have longer days than we do during the winter. So what do we write down? One hemisphere is tilted towards the sun, while the other tilts away. This is why one hemisphere will have summer while the other one has winter. Pause here if you need to write this down. I will be erasing to move to the bottom of the page. Last picture. If Earth's revolution around the sun looked like the illustration above, would we still experience seasons? Why or why not? You have to notice what's different about this picture compared to the first one. This picture doesn't have a tilted axis. In this picture, everywhere on the picture, Earth's axis is straight up and down. So if Earth's axis is straight up and down, neither hemisphere tilts towards or away. So if the Earth was not tilted, we would not experience seasons. The answer is no, because neither hemisphere is tilted towards or away. That's it for these season notes. This will be for a stamp.